just gonna record this bit because people asked who can't come along to see the stuff. So
All right, can everybody see this?
yeah, I can see that.
Yep.
All right, B2 demos and processor drive. Got two 9mm linear rails supported. Going the link 35 kilogram turbo, moving it forward and back, and then a 65 kilograms turbo. Providing up and down motion.
Nice.
Of course, wheels. These are Andy Mark 4-inch HD and Canon wheels. It's got a Pololu 530 RPM 24-volt motor. It's got a Sonic hub by Gold Builder that straps securely onto the D shaft, and it's got bushings. Some bushings and washers, and a little keeper to keep this 100mm 6mm diameter shaft in position here. And that is right there. Shaft column. All right, so the next step is to get a bracket to mount this securely into the droid and print 3 more of them and attach the shells. Other than that, we're looking good. All right, so I should be stopping the share here.
Yeah. Oh, that's great, Tim. And you're using 90 degree that servo, are you, on them extenders?
In that, it was using 90 degrees, but it probably only needs about 80 degrees on the up and down, and similar for the fore and aft, because I've got the gears really big, so you don't have to get full range of motion or even close to full range of motion to tune them into the right position.
Right, got you. Okay. Oh, brilliant. It's yeah, so the next thing is to mount it all and see how it runs.
Yeah, all 4 of them. So the bracket's going to be challenging, just to grab the side of the droid and imagine sort of like a shoulder slot or something to beef up the side, and then bolt that on. And the rest of it is probably a couple weeks away of printing, and because I need the body. I need to print the whole body, bottom part, to test its structural integrity and print out 3 more drives. And so I'm to the point where I'm going to commit to the building 3 more drives and mounting them in, and then if it all works, we'll have a complete drive system.
Yeah, it's not a big droid really, so it's we're not carrying an R2 size thing around, but there's a lot of mech in there, so there is a little bit of weight. Well, I said I think the key to it is keeping that center core structure solid without having any movement on it. You had springs on there as well. Is that for?
Yeah. So when the servos are depowered, it rests on those springs. So the weight of the droid will be on those springs. The theory being that if you go over a bump, the spring's gonna, and they're fairly stiff, it's gonna push the wheel down and try to keep it in contact.
Right. Okay. So even when they're active, when it's rolling, them springs will help to keep the wheels in contact.
Well, as long as it's not extended. When it extends up, the springs don't press on anything. It's only when it's fully compressed.
Gotcha. Yeah. Okay.
And I don't know if you want to be driving him around when he's fully extended anyway. That'd be kind of a static in one position puppetry thing, rather than going down the road at 6 miles an hour, spinning up and down.
Yeah, exactly. We're gonna have to play around. But no, cool, fantastic. So tonight I think we're going to do a little bit more of the tech stuff. So I was going to take you through the body and the head. So I managed to assemble the body and head now, not with outer panels. I took the outer panels off so you can kind of see how it functions, so we can have a play around with that. We've also got Mr. Pearl, I think, who's going to do us a little bit of an update on human cyborg relations. How's timing with you, Michael? Do you need to jump on first and then you've got to get off, or?
No, I'm actually good. I'm just getting a little stuff done now, so I can idle while you do your B2 thing.
Yeah, cool. So the plan was we'll go through a little bit on the B2 thing, and then once we've gone through that, we can jump on to human cyborg relations, and then we'll break out into some of the rooms so we can start to take some of the tech, if that works for everyone. So I'll kick off then, actually, on the B2. I was going to record this session because a few people I know couldn't make it and they wanted to watch it. When we break out into rooms, I'll stop recording them because we can't record the individual rooms. But right, let me see if I can share the screen. Can people see that?
I see a black screen. There we go.
There it is.
Okay, there you go. So yeah, I'm just going to talk you through the overall design. I think you've probably, or you've seen a lot of the head mech. If we strip the panels away, there we go. This is the head mechanism. So I know a few of you guys have started to build this, but what you've got here is there's a servo here that does the lift. There's a 360 joint in the middle. Ignore that ball. That's just my point of reference. And then there's two servos at the side here and here that they do kind of the pan and tilt, and then we've got a Lazy Susan on top with a servo, so that does the full spin. So I think you've probably seen some videos on that. The middle frame, just take this. So this is Alex. The way we kind of do this, we're doing between myself, Alex, and Tim. I did this top frame first of all, and then what Alex has done is took this basic mechanism, which is an 8mm 3D printer bar and a 45mm linear bearing. So what I was saying before was that if you can imagine, once this is fully loaded with skins, you've got this center core that goes right through the center. If there's any play on that left to right or any wobble on it, you'll see it on the droid when he moves around. So I wanted to build something that was absolutely rock solid. So the critical bit to it was making sure that all of the different platforms that sit within this concertina Big Mac, as I like to think of him, is each of those have got to be really, really solid. So I thought I'd play around with these 3D printer bars and extended 45mm linear bearings, and it worked really well for the head. So what Alex had done is Alex gone through 3 iterations. First was a scissor one, which wasn't stable enough at all, and then we went through 4 bars, which it was getting quite tight to fit everything in there. So what we've got now is we've gone for this 3-bar mech. Exactly the same as the top with these 45mm linear bearings on this Y piece, which has got B2 written on the side of it in Arabic, so which is cool. And then this kind of a L shape, and then what you've got is this second set of bars and bearings, which then enable you to do this second platform. So that gives us about, I think it's 50mm lift for each body section. And then I don't know what the head lift is actually. I think let's have a quick look at that. 60, yeah. So about 60mm at the top. So you end up with about 162mm, and I think you've got another 50mm in the feet, haven't you, Tim?
That's correct.
Yeah. So you've got this kind of false concertina stuff, and then stretch. A few people have been asking me how tall he is, and it really depends on what state he's in, but fully extended is going to be above well above 600mm. I think about 640 I think I'd measured it at, but obviously he compresses and stretches out. So, and then the other thing which we've really tried to play with is servo strength. So on the heads, all 35kg servos, which are more than enough for the head mech. But progressively as we go down, it gets more and more weight on these servos. So these 2 bottom servos, that one and that one, which lift the 2 individual sections, are 60kg servos. again, it sounds a lot, but that 60 kilos is 1 centimeter from the hub, so it's 10 mil out about there. So the further you go out, so 20 millimeters, it's actually a half of 60 kilos, so it's 30 kilos. It can lift, and then at 30, it drops down even more. So it can lift around about 20 kilos, which is more than enough for what we've got so far. That's the theory, but of course, when you put it into practice, you've got to kind of test that. The other
Joe ahead parts.
Sorry, John. Oh, sorry, I thought John's asking something. The other consideration then is the spinny rings. So when you've got all the skins on, you have these rings that spin round. So not only have we got to get a lifting mechanism, we've got to get rings on the inside that spin. So the kind of way, okay, where's the middle frame? Yeah. So we've then got almost like an R2 dome mechanism. So you've got 2 of those, one at the top and one at the bottom, and they effectively spin the rings on a couple of lazy Susans. So once you've got all that in place, it does get quite complicated, as you can imagine. So what we've got is, you can just see in there, there's a lower ring that spins, there's an upper ring that spin. These 4 outer edges arise as they stay still. So it's been trying to get everything fitted in, but then the other consideration, of course, is how do you assemble and disassemble it once it's in this position to get to stuff. So what we've got then is, if you take the head and the head and the hat come off with a single screw off the top, and then the way I've gone for it really is that there's then literally 4 bolts on here, which actually then bolt this top frame in. So this top frame will then completely lift off. So once you take 4 bolts out, you'll take that piece out. Then you've got 3 more bolts, and you'll be able to take the midsection off. So literally with eight bolts, you'll be able to get it back to this state. So this is really what you learn as you go along on designing of these. And one of the things I learned with DO is it's great to get things working, but then you've got to work out how you take it to bits afterwards to change batteries and do things. So really trying to work on creating more of a triangular shape so that you can put the layers onto the top and you can take the layers off. That of course means if you want to change the skins, it becomes a lot easier to change the skins. We've not kind of worked out what we do on the bottom yet for that. Does that kind of make sense as a design?
Mm-hmm.
Yeah.
So the battery's going. The battery's going in the bottom.
Yeah, in the bottom, we've literally got all this space complete. So what we wanted to do was, what I really wanted to do was get everything that contained within the layers. So you weren't eating into the lower space at all. Obviously, Tim's mechanism for the drive will eat into this space a little bit, but what it does mean is we'll have all the weight in the bottom again, which will give us some stability. And this is why the three big considerations to making this look really good. The first one is suspension, which Tim showed, having the springs when it's in the lower position. So if we can get some suspension in this bottom piece, it'll smooth it out a little bit. The second one is really solid platform, which is all of these linear bearings and the strength and solidity as it goes up and down. And the last one is servo smoothing, because obviously if his head moves around jerky left and right, it's going to shake the body irrespective. So all 3 of those are kind of considerations that we've got. The other thing, of course, is when you've done all this, and you start to tot up the
friends talking about robots.
Sorry. Oh, no comment. Yeah, so when you start to tot it up, it's quite scary. So there's going to be 14 servos in this and 6 speed controllers. So when you start to think around when you put in RC on, even if you've got 10 channels, how many fingers and hands have you got to control this damn thing? The real one obviously had 3 separate controllers, 3 people that controlled it. We want to try and get down to one person that controls it. So what we've got to do is build some automation in there so that you can do things like lift the body and it spins the interior rings, etc. So there's a lot in it. But that said, it's a nice build. It's a solid build, and it's actually great fun. So that's where we've got to so far. Design wise, the head's done. This middle body is pretty much done. The lower, so all of this mechanism that you can see here is pretty much done and working. What I've got to do yet is add the lower Lazy Susan and the lower revolving ring, which I don't think is going to be much of a design fleet, but it is turning out quite solid. I'm going to stop sharing there for a minute. Yeah.
Oh, Jeff Kalman. Question: are you going to be able to? Is this the size of Chopper and R2 in that we'll be able to have full size prints on an S5?
Yes. Yeah.
Okay.
Yeah, it's not. It's actually slightly smaller than R2 and Chopper, so it will hold up on a full size S5 or a 500mm bed. In fact, the body is just over a fraction over 400mm. So if you've got 450, we're okay. 400mm, it's going to be really tight to do some of the body panels, but all the internals will do on a 400mm bed. At the moment, I'm printing most of this on Prusa.
Michael, I've got a question.
Yeah, go for it.
Do we have an overall maximum width? I'm thinking for getting through doorways and things.
We do indeed. It'll get through doorways, I'm pretty sure. But Tim, have you got a width? Because you're playing with feet, which is the widest bit.
Let me take a look at it. Stand by. Accessing.
Yeah, we'll have a look. I'm fairly confident, Steve, because it is a slightly smaller unit than R2 and Chopper. I mean,
okay, because my R2 barely squeezes through a standard UK door.
Yes, yeah, mine does.
Yeah, we won't have the legs sticking out like we do on R2 either, Steve, right?
Yeah.
Oh.
Well, I mean, because they stick out either side of the body, but then obviously the body's a lot narrower than R2's. But I've got no idea of the overall dimensions.
Yeah.
So let me hold on. I'm measuring. For some reason, I'm getting an odd artifact here. So 645, call it 646 millimeters from the outer shell to the outer shell, currently as configured.
Okay.
He'll get through a doorway easier than me.
To get through a doorway, yeah, definitely.
yeah. So it's about 25 and a bit inches, something like that.
Yeah.
Can I just say, I don't know whether anyone else noticed that the American there is using the brilliant metric system. Or was he forced to because he had to work with Badley on this?
I can answer that. Metric's easier to design in because you don't have to figure out if 3/8 is bigger than 5/64. It just 3 millimeters is smaller than 4 millimeters, et cetera, et cetera. It's just way easier to design. So
maybe us Brits are actually on something.
Well,
I do everything in metric. We're all of us are crazy over here.
So is that a bit like that story of the American burger chain that tried to sell a £3 burger and people didn't buy it because they thought it was a quarter pounder?
So yeah, so just I don't know if that kind of is that on screen now with the main build.
It's on screen, yeah. Can we make you full screen?
I've got it. I think I've got it on pinned, have I?
I see it.
Let me try pinning it again.
I think so.
Spotlight for everybody. Is that better?
Oh, cool.
Yep. Yeah. You can see it now. Yeah. So you've seen the mech. The head mech goes obviously up, down. You've got the left, right turn. I haven't got servo smoothing on this yet, and then obviously you've got the look down, left, right, and all of the different tilts. So that kind of works. So the body mech, you've got 2 servos. So
wow.
So you can see it is crazily smooth and crazily solid. I am absolutely delighted with this as a kind of build for it to get the platforms that solid. And what it does mean is that you're not just going out concertina light, but you can kind of wave the middle bit up and down without the head
Wow.
moving.
That's incredible.
The other piece with this is that when the servos are fully extended, you're actually resting on the arm of the servo, so it's not putting load directly on the servo. So which is really important. I mean, the 60k servos, and they will carry a lot more weight than what's on there. But obviously, when you're running down at half, you're putting stress on that servo arm. So it does mean that you've got full extended. But with those 8mm bars in there, it's pretty solid. So you can, and again, it's just, you can get some really kind of nice effects. Once we've got some smooth controllers on there, it'll be very cool.
So, Michael, I have two questions. One is, I'd like to be able to, on the skinning thing, I'd like to be able to separate the head from the hat, and that seems like that would be a pretty easy change to make.
Yeah, absolutely. We can. The head prints. I'm trying to think what orientation the head prints in, but yeah, simply at the moment, it's glued in, but it makes sense to make that separate.
Yeah, I think you could probably just have some printable brackets that you put in there that you could screw through. The other thing is, have you seen James Bruton's drive build?
Yes, I have.
What do you think of that? I don't know if Tim, if you showed anything in detail on this, but one of the things that I really like about what he did, even though it's kind of creative, but the feet will tilt nicely. In like a reasonable response to the motion of the droid. I'm just wondering what your drive system is going to do in those situations.
It's got the same theoretical capability. I haven't checked it yet, but he cheats with his drive system.
Totally.
That mechanism will not fit inside the constraints of a B2. So he was trying to do quote unquote a budget build by using his like forks for lifters and whatnot.
Yeah, lighter servos and stuff.
Yeah, where it rotates instead of slides. Mine slides. Yeah. So I put again the 8mm bearings and bars and a servo to move it. And so although his is very elegant, it doesn't quite fit the bill for what we're trying to do. And even with my, I would say, slightly more expensive approach, even that I'm still making some assumptions of stuff that has to happen, but I don't know how they did it without. Maybe they use linear actuators, and I'm just using all 180-degree beefy servos. With
I'm assuming there's some linears in there. So are you? I see your feet go in and out and up and down, and the question is whether they can turn, and that maybe that's in there, and I just didn't spot it.
Well, his don't turn per se; they just kind of tilt in plane. Let me see if I can share my screen and.
I mean, I guess the skins could move relative to the foot. Also, I'm just.
Yeah. Let me share my screen. I'll do a quick overview of what's going on here. Hold on, let me find Zoom again. Zoom, share screen, desktop, share. All right, do you see Fusion?
Yep.
Okay, so this is kind of the concept, and you can see I've got this little slot here, which I don't see in any of the videos, but you don't really get a look at this. That's where the wires are going to slide forward and aft and not get pinched. This servo here, that was just a concept of where I might want to put the servo if I just broke it apart. Stand by. Find the browser. There. I was just playing around with an alternate servo location. But basically this mech here, you're gonna have 4 of them. And turn the shell off. Looks a little bit like this from the outside. So you got the motor box, which has its drive train in here. I've got so many pieces here. here, right foot. I thought it'd be easy to find. Give me 1 sec here. 8 million, but so. Here we go. Drivetrain version 5. So the problem is getting all of this mech inside the constraints of the skins. So it starts with the Mecanum wheel. This is actually, I think the original one had a 6-inch wheel, and we went with a 4-inch wheel just to give us more space. So that's the front right foot. And then inside the front right foot, there's a leg longer. And we've got a servo. Again, it's one of these giant 60-kilogram servos. But what that does is it drives that motor box up and down. And if you drive one side up and the other side not up, the whole droid will tilt. So the wheels aren't going to necessarily rotate around an axis because it's only driven up and down in a vertical plane. But if you drive the front up or don't drive the back down, the whole droid will tilt and it'll rotate about the wheels, if that makes any sense.
But the foot shells will stay level though, right?
Well, they'll stay in the same relationship to the body. The foot shells don't change, but it's like jacking up the front of a car, sort of with a hydraulic lift. It's
the feet will tilt with the body. Okay.
Well,
yeah, I thought I saw the actual droid, the wheels doing this, tilting the front and back toes, essentially tilting down.
That motion is not available in this design, because the only tilting and rotating is going to be about the axle of the actual wheel on the Mecanum wheel. That's going to be the rotation point as the front jacks up and the body backs down. Let me see if I can turn my wheel back on here. So if I move this, not faces, but components. If I move this unit down, that's going to drive the front of the droid up. And if I don't move the back, the whole droid tilts.
You'd have to have separate motors to spin to turn that whole foot shell to get what you're talking about, right? Where it kind of goes up on its tippy toes. And then 4 independent motors.
But with that, there's absolutely no clearance for something like that to happen. If you look at this, all the pictures, there's like a millimeter clearance between this foot shell and the body. There's absolutely no way that this shell is rotating in any fashion, and it doesn't go up or down. The foot itself is what's going up and down
inside there. Yeah. I think it's beautiful already, and we've got to be approaching $1,200 to $1,500 just for the bottom part there. I think. Motors, servos, rails, bearings.
I don't know if it's over $1,000, but it's not going to be cheap.
Not under $1,000.
No. Well, I about a month and a half ago, I did a spreadsheet with all the bill of materials, and it was at $750.
Yeah, I mean, so James's feet don't remain parallel to the floor, but what James's feet do is they both tilt. But the challenge, like Tim said, if you're actually constrained by the shells that are on there. So if you tilt, you're going to either have to eat into the body, or potentially put a hinge.
Yeah, he may run into some trouble when he tries to do the cosmetics.
Yeah.
With that.
Yeah, his will not fit in this shape because the side of the one we see on screen has these little indents here, and as you can see in my my model, I've got some cleanup here to do, but the slide wheels actually are hanging and somewhat hiding inside of that area, and not completely hidden, but you can't see the ones on screen, but they've got to be doing something along those lines of hiding a sliding rail underneath the side detail.
So if you raise that outer foot up and down that has the drive wheel on it, on one end of the robot, both sides, I guess it just pivots on the Mecham roller sideways when you're only using the other half to drive it. It's sitting at an angle and they're just using those as a roller, I guess.
Yeah, if I move this down, this whole unit down by that much, and you can imagine that the other side is also moved down. Let me see if I can find that foot.
Yeah, there's
So if these two are moved down by that amount, and I'm not sure there's what happened there. I think I have some joints that are interacting with each other, but let me turn the other legs on. You can see if it's sitting like that, the whole body is going to tilt back. And if I do the opposite, it's going to tilt forward. And if you do a slightly different, it's going to sway forward and aft as you go up and down, or left and right. You can do each wheel independent. So that's going to create a platform that will cause it to wobble up and down or move in specific ways.
Yes. So I don't know if you can see what I've just shared there, but that's what James has got. So his tilt, they're both tilt, so they don't remain perpendicular. So I think that's virtually the same mechanism that you've got, isn't it, Tim? There, because effectively one of those shells is higher than the other shell, but they're both in parallel to the body.
Correct, but the big difference is the angles where it's tilting and what's causing it to tilt. The big giant forked sway bar suspension things is really the part that like the whole bottom has to be open to have that slide those wheels fore and aft, and ours is closed and very much sealed.
It's no different, Tim. Like if you look at the angle of the feet here is parallel to the body.
Yeah, they are.
Even though it looks like the feet are tilting, it's because the body tilted.
Yeah,
right.
You're right.
I agree with
which
that.
is exactly the same as yours will operate, isn't it, Tim?
Yes,
with
the
correct software.
difference though is when he moves they are going they're traveling in an arc because they're on those forked lifters, where mine are traveling vertically and stay in the same plane. His are moving in a small arc as he goes up and down. And
which is where you'll have a problem with the skin then when it's moving in the arc.
Yes.
Or he'll have a big gap when they're at effectively sort of like a neutral position. If they go up,
right,
you'll have a wider gap in that neutral position, and then they'll come in as they go up and down, won't they?
Yeah, and that the bar that's connecting it to the center has to go through and have a big giant gap or big hole in the side of the droid for that arm to move and slide in and out. So the whole base of the droid has to be open for that mechanism to stick out.
So this all makes sense. Can I show you something from the Disney stuff? Maybe I'm misunderstanding, but like this is the motion I'm talking about. Right there.
Yes.
See how the feet move? Are we saying that we think that'll happen?
Yeah, I think the last still frame we saw of James's build, where the feet are parallel to each other, but they're rotating about the wheel. I believe the same motion is going to happen with mine. It's just that mine the way they go up and down is more screen accurate, and the way they go in and out will be more screen accurate in appearance and mechanics. But I don't know how they did it, but it's got to.
I mean, it's amazing regardless.
Yeah, I'm calling it the Impossible drive because it's impossible to build.
On top of what Tim's designed, the next bit is the software to get the damn thing to work. Yeah, because to actually what James's one's got a mechanic, quite a bit of mechanics in there that drives the angles and the automation, whereas what Tim's got is he's built all of the electronics. What we've got to do then is sync those electronics with software, so that when
exactly what James was trying to avoid doing.
Yes, exactly. Whereas we like a challenge, but again, you're not then constrained by the shell because ultimately what you can't do is dig into that shell too much. Otherwise, the wheels moving in and out on the arc would actually be quite noticeable, I think.
And I think the biggest issue with that is not that small arc, but how it grabs onto the wheel, and when the wheels extend, is that thing that's holding onto the wheel has to have a path, and there's two of them, so it has to have a giant path that would extend out the front of the droid and out the back of the droid when you get to the full extension, and so that whole area would have to be open and not constrained. So I think that's the biggest problem with the design of why it won't fit.
Yeah. But
I mean, it's a beautiful design. I wish I had designed it.
Have you worked out how much that will actually tilt the head when it's fully extended up? Because obviously you've got what, about 45 millimeters of travel on them wheels. So if it lifts one side nearly 2 inches, will that move the head over probably what, 5-6 inches? Tilt it? If it's fully extended it. If it's at its full 600 mil height.
I think where you're going to have a limitation with that drive compared to the screen drive is the size of the mecanum. We're pretty sure that those mecanums are smaller. So you as you tilt, the foot shells are eventually going to hit, right? And that's just going to be a limitation. That's the way it is.
Yeah, and we went with the 4-inch wheels because the 6-inch wheels were $500 or $625. They were super expensive. And then you still had to find a place to put the motor. Which
Tim, did you check out these brushless motors for scooters with these hub motors, and thinking about like replacing the tire which is on it with I don't know, like printed wheel instead of this, because they do them in like 6-inch size, and the problem is that they are with tire, not with with right end of the wheel, but it could be much easier to implement because you need just hub and that's all.
Well, we did briefly look at brushless motors, and they have brushless mecanum motors that you can buy out of the box, but all those are just, again, we're trying to keep the price down, and it's not down, but it would go from expensive to astronomical when those are probably, were they $250 a motor, maybe, or even more.
The other consideration is availability, because obviously what we've got to build is something that's available in every region. So whether it's US, Europe,
these spare motors with tire are like about $80. Well, you have to order them from China, of course, but problem is that you need to, let's say, replace the tire with mecanum, which could be, I suppose, printed somehow, but it's additional work.
Yeah, I saw a video.
You've also got the brushless controllers, so it's kind of it's getting something that's accessible, that's available. There's a lot of choices in all of this. Really. Yeah.
But I talked to Dave about the mecanum wheels, and if everybody has seen his DJ Rex, he started with the mecanum wheels that were available on Go Builda. There were 4-inch mecanum wheels, and he ended up burning them up due to the stress that's on these wheels when you drive them sideways. There's an incredible amount of stress and heat that builds up on these wheels, which kind of talked me out of 3D printing them. Even if you could 3D print one that lasted for a while, the building and the maintenance, and it's just, in the long run, it's better to go with a nice, beefy, strong, well-engineered wheel with bearings, and that's what we have in these Andy Mark wheels. Is they're fully kind of battle tested. He's using them on his DJ Rex right now, and through consulting with him is where I landed on that particular wheel, versus any other wheel. Are they the cheapest? No, but they're just expensive enough to do the job. No more. I mean, we didn't go all out. We just went with what we thought would work in the long run and not cause everybody pain and heartache and suffering.
Exactly.
Yeah, makes sense.
So it's Tim, it's
sorry.
a go ahead and get those Anti-Mark wheels. That's not changing, right?
No, the Anti-Mark wheels, that's an integral part of the design. I've heard some people complaining or why did you go with 24-volt motors, not 12-volt? Well, that form factor, you can fit, you can take any 37D 6mm shaft motor. They're all exactly the same size on the outside, same mounting pattern. So if you want to put a 12-volt motor in there or something of a different torque, all that's possible. You can pick whatever motor you like, including Chinese clones. But I bought the Pololu 530 RPM 24-volt motor because that had the most torque and the highest, I thought, chance for working correctly in driving around the Droid. Obviously, I haven't tested it yet, but that was the one with the most torque in that. And also gave me enough speed that it wouldn't just be crawling at 1 mile an hour.
It's certainly it's a challenging build. It really is. Anyway, I'm conscious we've got Alec as well who's joined us. Hi, Alec. For the first time, I think. Hey, Alec. So, who ultimately really kind of designed the body on this, which is quite cool. So, I don't know whether you wanted just to talk through the pains and iterations of doing the body. Are you there, Alec? Oh. I can't hear you, Alec. No.
Any better?
Oh, there you go. We heard something then.
Right, you there?
Yes.
Perfect. Sorry, I was setting up for something else and switched my mic off. Yeah, so I had some fun testing a number of different designs, inspired by a lot of YouTube videos and stuff, trying to work out what's the best 3D printed mechanism. I have one here, actually, if I switch my, I don't know if you can pin my camera, but this is one of the early iterations of the scissor lift system. And the idea is this is the bottom section, and then you have the section above it to ultimately do it. And in the middle is a servo that controls this. A lot of people would suggest doing scissor lifts and stuff like this. When I tested this is the one that probably burnt the worst, running a 35 kilo servo, and just on that one little test holding up a Ryobi power tool, it burnt out the servo. So testing a number of different designs, we ended up on that one being probably the most mechanically efficient. And the hardest part was trying to get it in a way where we could articulate both sections independently. So the one thing we wanted to consider was when you animate this thing, compared to R2, this thing is highly dynamic in terms of how it can demonstrate emotions and stuff like that. So being able to articulate the body in different segments would allow us then later to demonstrate different ways on how to position the droid. So for instance, if it's happy, it would be obviously a lot more higher, a bit more responsive in its response curves of the servos and such. But if it's sad, it would be more compressed and more stuff. So being able to articulate that is going to be key to how this droid functions. So enabling those different tiers, I think, was a kind of like a prerequisite at the end of the day.
You've not printed this yet, Alex, have you?
No, I've only printed parts. So this is my biggest piece at the moment. The rest of it will be printing slowly. My biggest delay is obviously because I'm in Australia. Sourcing parts and stuff like that can be quite difficult. So motors are on their way. Those linear bearings and all that stuff, they're all on their way, but it's not going to happen until probably closer to November, end of November, when I get all the hardware in order to finish my build. But we had some fun. I think there was actually a couple of design iterations even of this one. We went with a, after the scissor lift, we went with a 4-pronged version of this. And that was quite what was considered dense. Like it was a lot to be fitting in such a small space. And while the concept worked, Michael, he suggested, why don't we just go 3, free it up a little bit. And so we went to a 3-pronged version and added in a little B2 in Albrecht on the front. So that way, freed up a lot of space. We could get better cable runs down through the central part. And then that also, the reason why we went for the 3 here at the front is because you can imagine this part's the back piece. So that'll face the rear. And then later on, when we work out how to do the vending capability of the B2, there's all this space now at the front that you can then build a vending mount to then pop open somehow. But we haven't worked through that mechanics yet because they've got a number of factors in that. You've got to align the central ring in order to make sure it all lines up properly. And then you've got to open pretty much 2 panels on the top and the middle section, and then open up the ring in order to allow the bending capability. So that is incredibly complex. And hats off to the designers and the engineers behind building that one, because that one is very impressive.
Oh, brilliant. Oh, thanks. What time is it there, Alec?
It is 6:45 in the morning.
Well, thanks for getting up early and joining us.
I appreciate it.
Yeah, so that was pretty much an update on B2. We're probably going to just jump into human cyborg relations, but before we do that, we'll just check on any other comments, questions, ponderings, thoughts, or humorous jokes.
Just a thought that had been crossing my mind. Had you considered using lead screws, like so 3D printer type ball lead screws?
Yeah, I looked at those. The challenge with those is it adds a lot more complexity to the build. So it's not just the lead screws. You're then running them on stepper motors, and then with stepper motors, you need a home position switch for it to. So when you power it off and power it on, it's got to go down, find its home position, and then stop. So just by switching over to those, what you end up doing is adding a whole load more logic and a load more kind of cabling around that. So
yeah, fair enough.
Servos are such a beautiful package because they always go to where you tell them to. They've got the limitations definitely, but if we can get away with using servos, I love using them for that reason.
Excellent. Thank you for the answer.
No,
so when do we get the next bits?
Yeah.
I'm running out of stuff to print. I got this already done.
No, Sam. Listen, I've the body is the thing with these is I have no issue in releasing the prints. We can release them tomorrow. You can play with them, but I don't want to get buyer's remorse. So when you do it and then we go, oh God, what we need to do is completely redesign 4 prongs to 3 prongs. Everybody's bought, it's not just me, Alec, and Tim that have bought a load of stuff. Everybody else has bought a load of linear bearings, and I feel intensely guilty about that. So I like to print something first, play with it, go, oh my God, this is brilliant, and then release it beta testing as opposed to doing that. But I think what I've shown you tonight, which is the body lift, I am comfortable with releasing those files, in the next few days, really, for people to play around with it. The only caveat then that is probably the mounting part on the bottom frame, because I've still got to do some work on how that actually works. So and how that mounts onto Tim's drives, because again that's going to be quite the key one. But yeah, short answer, next couple of days, Sam. Long answer is if you want to print it, you do, but at your own risk.
Yeah,
and
I'm somewhat prepared for that.
For a smaller printer. Sorry.
Right.
What, sorry,
yeah,
Steve?
I mean, I'm on a Prusa also, so
yeah.
But yeah, I'm raring to go. I know that there will be some waste.
They're all printed on. Well, I've printed the whole thing so far on the Prusa because my S5 is under a big pile of dust and I've not built my ramp rig yet. So we'll stick with the 220 size ones.
With the current servo motors you're using to lift these the head and neck mechanism up and down, is there going to be very much payload capacity left over Or are we working the servos close to their limits? Like
No,
if you wanted to add,
ones I've done in the past, I've always underestimated it and then hit this brick where I've gone, oh my God, I need a little bit extra servo. So this time I think we've over-engineered them.
okay,
In theory. So, and you know, there's not a lot of science behind this, to be honest, Stephen. The science has been me getting two 60-kilo servos, building the mechanism, and then pushing it against the settee and seeing if it actually squashes the pillar for more than what I do when I sit down, which it appears to do at the moment. So that's quite good. But that assembly I've just shown there's got loads and loads of extra oomph. So you can calculate it. So you can go at 60-kilo servo. I'm stretching it out to 2.5 centimeters, which means it can lift about 20 kilos. And what I'm asking it to lift at the moment, with everything printed, estimated, is max about 7 kilos. So it's got double the capacity on those servos, I think. But as everybody who knows that use servos, you know, you buy 180-degree ones and they come in at 160, or they come in at 120. They say they lift 60 kilos, they might lift 50 kilos, you don't know. So they're over capacity, and they seem really comfortable as they stand at the moment. But if not, there's 80-kilo servos that I've seen, so which can probably break your finger. So, you know, get into the dangerous world of servos. Any more thoughts, comments?
seems pretty impressive so far. Nice job.
Yes, it's an exciting. I was excited. I've got the same feeling when we built Chopper, which is like this is really going to work together really nicely. The absolute make or break on this is just the drive system now. No pressure, Tim.
No, it'll break for sure. I guarantee. But the drive system really is going to come down to the components that we put in it. And right now, like I said, I've gone with the least expensive but just worthy enough options, which still makes it quite expensive compared to other drive systems on Astromex. Maybe BB-8 would complain about that, but if it's not, I've got a couple of knobs I can twist to make it more robust and stable without changing the components. But as I do that, I sacrifice the full motion of travel. Because right now I'm kind of doing like a cantilever type of mechanism to hold the drive onto the side of the droid. And the further I spread those two mounting points apart, the more stable and strong it'll be. But then we may lose some, well, we will lose some motion extension. Instead of going 85 millimeters, it may only go 70. But that's to be seen. It'll come with more testing. But I'm pretty confident that if we can hold on to the side of the droid strongly enough, the drive should be robust enough in its current state to at least move around. And if not, I wouldn't put it in any 39.1% races, but it should hold together.
Just seeing how much wobble we can create in it, but it's pretty solid.
So another question, what are we thinking in terms of actual remote control for this thing? Are we going to need a microprocessor driven remote control system?
Yeah, we need about 20 channel remote control system controllable by one person. So first of all, we need to evolve to octopuses as humans, and then secondly, we need to. Now, we've got some thoughts. Alec, I don't know if you're still there. I know Alex giving some thought on the control system.
Yeah. So yeah. Where do I start? So the thought process behind that is obviously how do you give control to critical functions, and that is your XY movement and the head movement. The idea that I was thinking, and I've been testing this on a Raspberry Pi based servo board, where it has enough of the pinouts for all the servos within the Droid, including the drive systems and so forth. But the inputs we can use in various ways to mix together. And where we go from there is how do we then use decision logic or a simple AI to then augment the operator by creating those in-between states. So what I mean by that is, as an operator, you might have your transmitter and you'll have, you might be driving along and then you want to switch to, say, head control. You would flip a switch and that would lock your drive systems, and then you have the ability to raise, lower the body, and obviously adjust the head position and so forth. But then there's all those little states. Now, if you sit, I've watched Andor way too many times to be sane at the moment, but watching B2 as he interacts with Cassian, you can see all the little inflections that he does as he communicates, like his thought process around, even when he gets asked to lie and responds with that's two lies. If you just look at the way his head positions and the way his body moves, there's a whole bunch of subtlety in there that we can't control as an operator. If you're a single operator, if we had three people, yeah, sure, but not as one. So the beauty of the Raspberry Pi board is just literally, if you check up Servo RP2040, built by Mori, that board has pretty much 16 usable servo outputs, and you can put pretty much anything into it. So what I've been testing right now, and it's all disassembled at the moment because I've set something else up, but essentially that board allows you to run a simple Python or C+ decision tree, and then therefore you can say, okay, I'm going to set the droid to be happy, and you can use a switch to that. And what that would do was, while you're trying to control the principal functions of the droid, all those little subtle movements, like the internal cores moving left and right, and the body compression ratio and all of that stuff could be automatically adjusted to how you want the droid to be presenting itself. So an operator, you'd go into a room, you'd set it to be happy, therefore its base would become a little bit wider, it would, its body extension would be a little bit taller, and the response movements to the head would be a little bit more snappier. As if you turn it to sad, the entire thing would compress a little bit, like it wouldn't be as stand up and stuff like that, and it would be a little bit more sluggish and so forth. So little things like that we can build into these boards that then you control the principal functions, and then that the decision logic or the AI can then control everything else, and it would simply just take your lead. That's the principle I was going for. So I've got some of it working. The only challenge I'm having right now is reading PPM inputs from controllers, because I use Graupner for a lot of my control units, and that is a bad way to go. So I'm switching over to FSCI and more generic ones, because the Graupner company, I don't think they operate anymore. So I'm using stuff which was built back in 2010. So and yeah, I don't have the configuration for it anymore. So I've ordered a whole bunch of different receivers, and I've got my TX16, which I'm going to test out and see how animated we can make this thing with the simplest of inputs.
I also have a TX16, so that'll be
They're
good.
awesome. Yeah, I got my little beauty down here ready to go. But it's paired now with a Graupner receiver, so not ideal. But if you look at the size of the board, so this is the setup I've been mucking about with. So that's the board compared to the servo. So the servo is actually bigger than the board. But these things are incredibly diverse in terms of how you can use them. But I think, yeah, it's just my receiver, which trying to read the PPM inputs to do all the channel mixing and everything makes it, it's not frame locking properly. So I ordered a bunch of new receivers.
That board is just a multiplexer. It doesn't have any memory, or there's no storage in it.
It does.
Oh, it does. So is it similar to a Maestro in that?
Yeah.
No,
So
there is full feature.
Circuit Python at the moment. And so it does have about 900 kilobytes of memory.
It's full featured dual core Raspberry Pi Core processor.
It's single core, this one. So it's quite linear in its operation. But you can, especially with Python and C++, there's ways around where you can do parallel processing using asynchronous functions. So what I've got this running currently is it'll use one process to manage all the servo outputs, and the other process monitors the inputs and does all the decision logic. So right now I've got the thing moving the servos quite comfortably, but as soon as I read the PPM inputs, I'm kind of getting junk. If I get it synced up properly, I get a good frame lock. But then as soon as there's one slight tweak, it loses its frame lock. And that's largely because the receiver is running Graupner's Sum D, I think, from memory. And I don't have the transmitter anymore to reconfigure it. So I just need to get some standard FR-Sky receivers and stuff and sync it up to more commonly available hardware.
Cool. Gimbals will help.
I have a one more question on this structure for the neck, the head, and all the mounts. What type of plastic are you printing that with?
I've gone with PETG, Stephen. So again, like most of the builds, PLA and Plus and PETG tend to be, they give you strength and a little bit of flexibility so it doesn't break.
Okay.
So yeah, that's but yeah, the design will work in PLA. PLA is a little bit more, well, it's a bit more solid but fragile. PETG's got a little bit more flex in it. PLA Plus has got a bit of flex in it, but to be honest, it'll work in all the filaments really.
Okay, thank you.
Cool, no problem. Cool. Any more on B2? Otherwise, we'll jump over to hearing more about the R2 vocalizer and human cyborg relations.
Michael, if you will find time, I would like to discuss my control system, which I believe could be usable using same processor as this Servo 2040 board. So maybe different approach a little bit, custom board or like full open source, and it could daisy chain the boards. So, and I'm working with situation that you would be able to run like DF player for sound and NeoPixels for lightning, and it supports scripting and stuff like this. So again, just if we will have time to discuss this, that would be great.
Yeah, that'd be cool.
Wow.
I think the main bit is trying to, as Alex said, the main bit is trying to read RC signals in, because RC controllers give you a lot of flexibility. You can do trims on them and controls. You can do channel mixing, and then being able to fly by wire that out to some kind of servo. So whether
I'm supporting,
PPM,
I'm supporting SBus. I'm already using it in R2 for running sound and showing lights and stuff like this. Well, technically, it could be compiled for this small Raspberry or ESP32. And if you compile it for ESP32, you can even drive it with Xbox X controller over Bluetooth, which I'm using on small Droids. But the software is the same. So this is the target. And what I expecting that it will be daisy chain through RS485. It was recommended by Trevor as like safest way how to daisy chain boards in Droid. And so each board would get like full SBus signal, all SBus data, so each board can react on their own. So for example, you can have like one board for drive, just for drive, and with all scripts in it for drive, and second one just for head, for example. But yeah, we can discuss it later.
Oh, definitely. Cheers.
Michael, did you say that the 8mm rods are the same in the lower section as the upper? They're all the same size?
well, it's the same 8mm rods. The ones on the body lift are 120 millimeters long. So I mean, I just bought 400mm ones, I think, and then cut them down with the Dremel, but they're the same type of rod. It's just the lengths in the body ones are 120, so you need 620 mil rods, and then the linear bearings, which are 45mm linear bearings, are the same.
Yeah, I got a pack of the linear bearings, but on the rods, I only got the 2 for the head, but it was a place to custom cut them, and it wasn't any more expensive. So
yeah, that'd be cool. What 120 mil you want, and you'll need 6 of them for the body.
All right, thank you.
Do you glue them to the plastic, or are they screwed on, or what holds the ends?
They're in a triangular bracket, so which I can show you. So don't know if you can see that. Is that sharing?
Yeah.
Yeah. So this
Okay.
is the rod. So the rod goes into the plastic, into a little hole there, and then you've got these triangular bearings that, triangular brackets that hold. So there's a triangle that goes out that way, and triangle that goes out that way, and then the inner frame basically holds the center bit, so it doesn't fold in, if that makes sense. So you end up with a very solid build, and then similar on the inside here.
So you just sandwich them in and screw it together, and
Sandwich them in, screw it together, yeah. And then what Alec's done on the folding design, which I really like actually, is as these 2 triangles actually fold together. So as this one drops down, it basically ends up almost touching this lower one here. So you end up, it's really compact in space, but very solid.
Wow. Nicely done.
So yes, yeah, nice design. Cool.
Sorry, that was
Okay,
short.
Mr. Pearl, are you there? Excellent. So tell us a little bit more about what's been happening in human cyborg relations.
Okay. Where to start for this? Let me.
You can talk
Let me,
about
I guess,
B2
first
if you
give
want
like
to,
a.
or you know.
Sorry.
I said you can talk about B2 if you want, because we need a vocalizer at some point, of course. But...
B2 is a tough act to follow, I have to say. So I guess like a very kind of broad overview on what this vocalizer is, for anyone who kind of didn't follow along and see the app version. It was, the idea behind this was all of the old kind of Droid sound systems were soundboard based. So you would be using your controller to queue up a particular pre-recorded vocalization. You could kind of randomize which ones you were picking, but broadly, there's not a lot of variation. You're kind of, you have to kind of know what sort of kind of organize them mentally, think about which one you're triggering, whether it's appropriate for a given circumstance. It's, it got the job done, but it was kind of a very crude system that in my, it doesn't live up to kind of the complexity and depth of kind of visual mechanisms that you guys, put so much attention into, B2 obviously being a perfect example of that. So the idea behind this vocalizer was, instead of having these a list of pre-recorded sound files, reverse engineer R2's language, basically go back to the process that Ben Burt used when he was designing these vocalizations for R2, and create a vocalizer that, instead of working at that kind of individual sound level, which would be impossible to juggle at the same time you're trying to handle a visual performance, kind of distill the communication layer down to using emotions as inputs. So for example, you say, okay, something funny just happened, so we want to trigger a happy vocalization, or something sad just happened, so we want to trigger a sad vocalization. Offload all of the decision-making process to what is effectively an AI in the software that decides, okay, we know R2 is feeling, in this instance, sad plus like a tinge of happiness from something that previously had happened. Track his emotional state, use that emotional state and the stimulus that you as the operator provide to then tell the AI, okay, we want to assemble a vocalization from this collection of various sounds to create a response that sounds appropriate given what we're trying to, the emotion we're trying to convey, which all, it sounds, it's a complex process and it sounds complicated, but the end result as an operator is all you have to do is think in terms of emotion, which is already how you're thinking as a puppeteer, as a performer anyway. So if you want to know kind of more about the process of building the software and the research that went into it, human-cyborg-relations.com is the website. And there's a nice, there's a write-up there, and I did an interview with Lee Towersy like 2 years ago at this point, maybe 2 years, something like that, where we kind of go more in depth and I talk about the process, which involved basically taking all of the recordings, all of the existing recordings of R2, breaking them down into a subset of unique sounds. And the granularity of these sounds is tiny. I mean, a lot of the things that kind of casually you would interpret as being like one sound are actually made up of like 20 different phonemes that then are sometimes repeated in different sounds or different vocalizations. Is there a question?
Yes. I was kind of wondering how you did that. It's like, are they, you said phonemes, or they're not like MP3 files you glue all together? They're some other way you've broken down those sound effects and combine them quickly.
Yeah. So there's more info on this on the website, and it's even a lot of text. So if you want just a more digestible version, check out the interview. That's an easy way to get it. But basically, I took the same collection of lossless audio of all of the vocalizations that you guys have been using previously, and just went through and isolated each of the individual phonemes, cut them down, organized them, cleaned them up, had to do some restoration on some of them. And then those become the database for the software. And then the way those get linked to a particular emotion is I then went through all 9 Skywalker Saga films, and for every single vocalization that R2 makes, I identified each of the phonemes that are present in each of these, in each vocalization. Wow. So that then becomes kind of a separate database where we know kind of emotionally what R2 is conveying in these different instances. So from that database, I built an AI that can basically it recreates Ben Burtt's process in real time. It decides what phonemes to select that are appropriate for a given emotional state, and recreates an R2 vocalization that, and this was kind of the project mandate that I set, which was every vocalization should be unique. So there are like very subtle kind of pitch and timing adjustments around each of these phonemes. All of those rules are dictated by Ben Burtt's design process. So because we have this database, we know how phonemes can be arranged, how they can be manipulated, and how those different arrangements and manipulations convey particular emotions. So it was the whole thing's absurd and like, more than it's worth getting into now. But the bottom line is like, so this became an app-based version of this vocalizer. So if people wanted to use it in their builds, you had to have a Bluetooth receiver. Bluetooth is not super high quality, not super reliable. So one of the requests that I commonly got like 2 years ago when this launched or whenever it was can there be an embedded version? And so people would want it to be running on like a Raspberry Pi. Not possible. Raspberry Pi, to be able to do real-time audio processing, you need kind of a very specific piece of hardware with a very specific audio library that can handle real-time audio is intensely complex and processor intensive. So the one platform that was able to support this is called the Teensy. And so slowly over the course of roughly a year, when I had time to spare to work on this, I was kind of working on porting it over from the app version into a version that can run on the Teensy. And it's finally there. So it's about ready to go. And I got a ton of help on, Alec, who is also the star of the B2 segment and will be the star of this segment as well. He helped a ton with the comm side. So making sure that controllers will be able to communicate with the Teensy and trigger these vocalizations. And then Trevor, who I think is here as well, also helped with designing a board that will make kind of the assembly and sort of hardware structure a little bit more digestible for people who maybe aren't kind of, you know, electronic savvy and aren't able to do kind of like really fine soldering. So I think possibly either or both of them have a demonstration that's maybe ready to go that they could bust out for us. But the bottom line is, if you know the app version of the vocaliser, it's the exact same functionality, same software, just running on the Teensy, which you can embed and then communicate with however you like. So Alec or Trevor?
That works offline, does it, Michael? Yeah. So you're not going to be connected. You just...
Exactly. It's totally self-contained.
Brilliant.
Totally offline.
Do a bit of a quick demonstration. So just to prefix this, finding Michael when he would produce the first version of the HCR via the mobiles, I'd already planned out this huge complex journey of going down this, and I was thinking it's going to take me 5 years to get this stuff, and I was already laying the groundwork, and then he came out with this, and I'm like, that is exactly what I'm looking for. I have to reach out to him, and I have to work out how I can build this, because I've been going for self-autonomy within the Droid, and this basically just enables the entire vocalization capability of what I was hoping for. So I'm just really, really happy that Michael accepted my input, and I'm so lucky to have been working with him on getting this to work. So I'll do a quick showcase of this is my setup to demonstrate. So this is all that it is. So we have the controlling microprocessor here. This is the one that will be issuing the commands to the board. We have the Teensy board on a custom shield just to interface it, and I use an I2C backbone to send all my commands. And then I have a simple Arduino Uno on with a USB shield running off an Xbox One controller to trigger all the emotes. I'll just share my screen now. You can do this a number of ways. Obviously, your controlling software can obviously do the whole thing, but we'll demonstrate through the command line. Let me share a screen. Yeah. So you should be able to see the Teensy console, and it's as simple as issuing commands. And then if I turn up the volume, you should be able to hear them really well. So obviously short and long is, well, a mild emotion is 0, and a more complex emotion is 1. And then it does exactly what Michael has indicated is how it actually demonstrates it. But we added a menu into this as well, so you can just see the ability to control it via the console as well. So you can go, okay, I want to trigger an emote. So you go 1, and then you want to trigger a happy. And then you've got the option of mild or strong. So we're going to go strong. And that also, you'll note here, is you can see the happiness level is changing. As we influence it, it adjusts its emotional states. So if I jump back to the main menu and I go to the emotive parameters of the board, you can see a happiness score of 85, sad is 0, mad is 0, and scared is 0. And I did allude this in the B2, you can kind of see the influence between the projects, is these allow the emotive state of the droid to be pretty well defined. So you can override it. So if I wanted to override it, and there's all commands in the back end of this, we can go here and just enable the override, and that locks down the emotional states, because you can see by the time I was talking, it's gone from 85 to 67. It's changed over time as it's normalized back to 0. So the override enabled now, it should stay at that state. So I can now set happiness to maybe 99, make it ultra happy. And then you can see status is 99. I'm going to make it a little bit scared, maybe 25. And we'll make it a little bit sad.
Wait.
Like that. And that will then influence how it then responds. So if I jump back to the main menu, and we go back to triggering it, you can see the emotive states have locked and they stayed the same. So now we can trigger a happy emote, but it's influenced by the rest of it.
Alec,
Sorry?
Alec,
Yeah.
every time you send, let's say a happy command, would it always play the same sound effect?
No, not at all. So if I keep pressing 2, actually, I'll just keep pressing 1. You can hear the difference. I'll move the microphone close. So if I press 1, again.
Okay, so there's a group of effects for whatever. If you send happy, you send sad, it will play one of these phonemes.
So each of those vocalizations that you're hearing are made up of about 200 phonemes, depending on the length. So not only will you never hear the same complete vocalization twice, ever, but the software is also intelligently checking for groupings of phonemes that are kind of more identifiable, and in particular, avoiding repeating groups of identifiable phonemes in close succession to one another. So the answer to will you ever hear the same thing twice is like absolutely not ever, on like multiple, like multiple dimensions of complexity is the answer to like no, that you will not.
So it's not like a random thing, it's just.
It is layers of informed randomness upon layers of informed randomness upon layers upon layers.
Which is where the humanity comes in, because that's how we all operate.
Yes, if something good happened to you, you would not give the same vocalization response twice in a row.
Ooh, and then we go, ooh, ooh.
Yeah.
Oh,
so
like talking to a blonde.
even the overload is different every time. So if we go back to the thing and I just execute an overload, and if we do it again,
that's interesting.
every time it is unique. And I've been experimenting this with my kids, and they absolutely love talking to R2 as a result, because every time it's just like they ask him a question, he can just give a quick happy response and away he goes. Or it can be quite sad. So yeah, they've really enjoyed interacting with it. And then it goes into your interfacing software. So if I exit out of that and we switch to the wider view, I don't know if you can see that too well, but when we use controlling software, it passes back a lot of this information. So you can query the board and then pass it. So I've got a little LED here. So if I make him happy, the system does not want to work at the moment. Let's reboot the board. Or it might be my USB shield seized up. Oh, actually, I know why, because I disconnected the RTC. That's my bad.
So sometimes I might say "wee," or I might say, "Oh, do it again." I understand. I get it. That's kind of cool, man. The randomness is more lifelike.
So here I've got Xbox One going through the USB shield into here to translate the input command, and then that sends the command via the HCR API into here, and then reads the response. So if I make him angry, he's still very happy, because remember I override. Actually, let me stop sharing my screen for a sec, just so I can see what I'm looking at. So you can see here the override is still enabled, so he's still happy, which is not what we want. So we're going to disable the override, and then I'm going to tell it to be sad, or actually angry, and you can see it changes the emotional state of the droid. So now red is obviously cranky, If I make him sad, like I can trigger the influence, but it's not instantaneous. You've got to nudge the droid along the emotional spectrum until he becomes sad, and you can see now it's quite sad. So this is an example of how the interfacing controller can then read and interact with you to change the state of the droid. And that's probably one of the most amazing things about this is the emotional side of what this is premised on is absolutely fantastic.
Yeah, to elaborate on that a tiny bit. So what's happening is there are 4 core emotions that are being tracked: fear, anger, happiness, sadness. And so when you trigger these stimulus inputs, it shifts the balance of those emotions. And it doesn't shift them entirely, and you can have kind of combinations of them because emotional response and emotional state is a spectrum. So you saw that demonstration that Alec made where he had set R2 to be angry and then triggered a sad stimulus, and R2 was still, the AI had determined that R2 was still more angry than sad. Without kind of seeing the underpinnings as it was going. It was probably something like, at that point, anger is, it's a whole complex algorithm. It's based on kind of human emotional flow, and also based on the kind of transition of R2's emotions over time in the film. So it's kind of, it's got some humanity mixed with R2's actual canonical emotional kind of depth, basically. So the vocalizations you get will be obviously very in line with whatever stimulus you just triggered, but will also be colored by kind of the underlying emotional state that R2 was in at the moment before that stimulus, in the same way that if you were angry and then something good happened, you would have kind of a positive reaction or a positive vocalization to it, but it would kind of be tinged by that anger that was diminished, but obviously still present.
That's interesting. Nicely done. Nice.
You can see that in the demonstration there, those lights as they change, they're just reaching thresholds. So if he's over 50% happy and over 50% angry, both the green and the red would be showing at the same time. But I think the best visualization demonstrating those states is your app, Michael, where you've got all the 4 bars and you can see each individual emotional state and how the trigger can actually influence it over time. And that's something which I think is fundamentally different from a lot of interactive embedment technology out there. It's
a bit like that animated film Inside Out, isn't it? I don't know if anyone's seen that. Where
yes.
Basically, that's what you've written, isn't it, Michael? You've written a computer version of Inside Out where you can shift dials and annoy R2.
That's exactly right.
Oh, fantastic.
So I've linked to the website and also the technical documentation for the software. The technical documentation, please don't buy anything. Same deal as Michael was relaying earlier about B2 and kind of work in progress. Let me publish kind of the final version, make the official final announcement within the next few days. At that point, you'll be safe to kind of start exploring and developing your control interface or buying hardware or however you want to do it. The thing to note with this is, so all of these human-cyborg relations projects that I've worked on are not for profit. So it's never paid software. I make nothing from them. But in exchange for using them, there is a mandatory donation that must be made to, for this one, it's First Robotics. Which is, I don't know if Nancy's here, she could kind of elaborate on what they do and why they're such a wonderful charity. But the bottom line is, okay, excellent. I'll kick it to you in a sec, Nancy. Okay. Bottom line is, if you want to use this Teensy software, I ask that you make a minimum $20 donation to First Robotics. So keep that in mind, look at the hardware specs and the software specs, make sure it's something you're willing to tackle, and then make your donation and I will send you the download link. So that's how it's going to operate. And the app version, I think, was a minimum $5 donation. And Nancy, if you want to kind of explain what First is and why there's such a great operation.
Thank you, Michael. I appreciate it. I love talking about First. So First Robotics, hello, everybody. It's good to see y'all. First Robotics is an organization that started back in the 80s that gives kids the opportunity to do robotics. And it started with a program that was mainly in the high school, and now it goes all the way through elementary. So we have 2 elementary age programs where students start learning basics and project management, and then do Lego type robotics competitions. And then they can move into middle school and do what's called FTC, where they build robots that are 18 inches by 18 inches in size, with aluminum and motors and, you know, a lot of stuff like what we do. And then at the high school level, they can build the big guys, as we like to say, the big brother. And those are droids that are very much, or droids, listen to me. They're robots that are very much like what y'all are building. I was amazed when I saw my very first R2 that had been built by a fan that was here in Lubbock. And he came up and brought R2 to my school and showed my students. And we looked at the inside. They were using, his R2 is using a lot of the same things that we were using to build our FRC robots. So this program is international. It's not just in the US, it's in all, you know, I can't say in all countries, but it is very widespread. It's really unique in that it allows students to not only learn and grow as a team, but also amongst other teams. You have a competition, but it encourages kids to help each other and cooperate as well, because in one round, they may be playing with 2 other teams together to score. And then in another round, they may be playing against the team they were just playing with. So it's really fascinating, and it's very much like our community, I think, in that respects. During the course of competition, you see other teams coming around saying, hey, how can I help you learn this? Or do you need help with anything or whatnot? And then, you know, next thing you go and look on the field and they're competing against each other. So it's a great place for students to learn about coding, teamwork, electronics, mechanical engineering, everything. So I appreciate that Michael's doing this, and that all of y'all that are going to get this really cool vocalizer are going to be giving to help schools with that. A lot of the money that is raised and given to First is used for scholarships for teams so that they can afford the registration fee to be able to compete in First. So thank you. It's a great organization.
Is First still a Dean Kamen project, or is that moved on from that?
Yeah, no, it is. He's still, he is no longer like the CEO, but he's, I mean, well, I don't know what his role is, but yeah, he's like an internal CEO, I guess you'd say. But he's definitely still involved and visits and goes to competitions and stuff.
So how can we enroll in this so I can increase my robot building chops? Sounds like a lot of these skills I need to learn.
Right? Why do you think I help with it? Because
Hello?
I get to learn all this cool stuff myself, you know.
Hello? I'm in a meeting right now with the robots right now. All right, I'll talk to you later.
I know that there are a lot of First mentors and coaches that are involved in this group. I'm not the only one. So, you know, if you find some and you have an expertise that you can offer them, and then that would be a great way for you to get involved. Also, I know there's so many people on here that have expertise that they could offer. You might even look around and see if you have a First team local to you. I'm sure that they would, you know, love things that you could share, even if it's just a visit from your droid. That's something that would really encourage and engage kids into the process and get them more involved. So it's always fun to find opportunities like that where you might be able to help some teams as they get ready for competition season.
Thanks so much, Nancy.
I think
awesome.
First is really cool. It's a great thing, and it gets kids involved. We did the same thing with robotic combat over the years, and both of us have grown up together, both of the ideas. And the best thing you can do is get other people involved or kids involved to stimulate their minds and pass on what you've learned. First rocks. It's really a good thing. Sorry.
They do. They do. They do.
So Michael, did you want to open it up to a question or two, or what are you thinking on timing?
Yeah, no, for timing, cool. Anybody got other questions on this? I've kind of got my head around it. I think it's amazing now because you can literally dial the emotions in. I think the key
we
to
might check out interfacing.
Oh, sorry.
So Trev has been working on a board to interface this whole solution into hardware. So while I've been working on the API, Trev's absolutely nailed a really solid interface board that would help integrate this with existing solutions.
Yeah, we should do that now for sure. Trevor, are you there and ready to show?
Trevor.
I'm here. Yep.
The Trevor Show.
Yay!
Not
Let's see
really.
Trevor. There we go. And look at Trevor's light as well, which is always impressive.
It is.
So yeah, I don't know if you guys can hear me okay or not, but so this is the board that I've been working on for the last little while. This is sort of version 2 of the vocalizer board that's available. It's going to be available in 2 versions. This version here, which is basically assembled, which includes the Teensy module and the audio board. So there's the base board, which is the blue. And then you've got the audio board, which is this first layer board here. And then there's a set of stacking headers that allow you to plug on the Teensy on top. So the Teensy can just plug in onto the top of it. So there'll be, as I said, there'll be 2 versions available. The DIY version, which basically will just be the board at the bottom with all the components on it. And then you'll buy your own audio board and Teensy board, and then you can solder them with the stacking headers yourself if you want to do that yourself. So that's basically what I've been working on. It has 4 communication interfaces available. So there's 2 serial ports like standard RS-232 UART, 1 485 port, and then it also does have I2C brought out on these on the side here. So if whatever your control system is that you want to use, you should be able to interface it. And then we have a power input and a line out. And there is a line in as well that's not used right now. And there's an optical out, which is not used right now, which maybe in the future there'll be some other functionality that might use those. But
are these boards assembled, or do they require soldering to put the port?
As I said, there's 2 versions. There's going to be a DIY version, which you'll have to solder the
header pins,
the headers on the Teensy, and the audio board and the stacking headers. The other components on the board, these components here, are all pre-populated. So it will come with those. You'll just have to put the other boards on. It's a little bit finicky to build this because of the way the stacking headers are, but we did that to try and reduce the size of the board overall.
I got a question on the configuration of the boards.
Yep.
So obviously there's the R2 vocalizer, but there's also a Astromech vocalizer. Is that software going to be installable and or configurable on this project? And go ahead.
So I'll answer that. Yes, it will be eventually. It's not available right now. We haven't as in Michael hasn't finished the port for it, but it'll be a new load that you will put on. And so you either have the R2 vocalizer or the Astromech vocalizer.
Okay.
How much did Trevor pay you to ask that question?
So in the future, yeah.
And a follow-up question, I noticed that there was a wave player in the interface that Alec was working on.
This is my Droid out. He has it installed. It's the first live one ever to live in the wild. And I'll just turn my light on and you can see, oh boy, that's terrible. So it's right down here and it's interfaced to my control system. So in my case, I'm using RC and mine's just wired to the various buttons. So I've got, you know, I can play vocalizations, all the different vocalizations. And then one of the really, to me, one of the greatest features of the item, not that the vocalizations aren't absolutely critical and amazing, but we do have the ability to play wave files. So we can play wave files. And then the best thing is that you don't lose your vocalizations. So you can play your vocalizations on top of your wave files.
So it records the vocalizations that you might have created?
No, so the wave files just play in the background and then they get mixed in and he still creates the vocalizations live. So they're unique.
Thank you.
They're everything with the vocalizer is intact and does not degrade with, it just plays on top of the wave file. And in fact, you can play two wave files at once, so you can do, you know.
Yeah, you mentioned before that you have it mixes. It does some mixing.
So is there an SD card that the wave files are stored on?
That's right. Yeah. So it uses the you can see on this one here, the SD card is right here on the top.
Oh, okay.
So you do need to put in an SD card for wave files. And then they're just yeah. And it's not, so it's not MP3. It does not support MP3 and will not support MP3. Only wave files.
I kind of skipped over that part, didn't I? But to quickly demonstrate what that looks like. So obviously we'll jump back to the Tinsy console and I'll get the camera just so you can see here. So there's the SD card on there. And I've just got 6 wave files because I'm not, but to give you an example, you have, that's up there. Sorry, I've got my system still talking to it. But what you would do is you would pass a command, CA. Now CA means trigger the WAV file on the A channel. And then you specify the file ID. So the prefix is the 4 digits and then whatever you want to call it. So I've got 0 to 8. So actually I'm just going to QF at the moment. QF won't return anything at the moment because I've disabled it, but QF would return how many files on there. So you do CA for channel A and you would specify the 4 digits of the file. Let me just check my volume and then you would play that. And you can hear it starts to play that file. So I can stop that immediately and play a different WAV file on maybe CB for the channel B. And I'll do a different one. And you can see the vocalizer still kicking in. So if I do CH1, SH1 for happy, it still plays. And then I can stop the WAV file immediately as soon as I want. And all this is configurable by the controller or the API that we've built. And then most importantly, along the whole thing is the config is all set by the SD. So your WAV files and how you configure all this is set in files on the SD. So you can actually daisy chain it all together. So you can do CA0000 for the first file. I'm going to do a happy response to trigger. And you can see it played the vocalization and the WAV file together, and you can play along as you go. So if right now it's sad. Thank you. And that's how it works.
Yeah, that kind of answers.
Is this basically a 2-channel mixer? You said channel A, channel B.
It's 3 channels, so it's two different wave channels, and then the vocalizer is the 3rd channel.
Oh, awesome! And they're all concurrent.
Correct. Mm-hmm.
So you could definitely do some awesome DJ work.
You definitely
Yes.
could. It probably would not be canonically accurate, but you could.
We won't
Yeah,
tell anyone.
that was my question, to be
Yeah.
honest, which is how the so in theory you could stack up R2's voice and actually get overlaps, but what you're saying is that the R2's voice just plays effectively on one channel, which is your AI channel, the one that and then you've got two WAV files that you can play the background music or background sound effects, and allows you to overlay
Nice.
that. Yeah, so that's a really nice way of bringing that together. And the two WAV channels literally just play WAV files. They're not altered or configured in any way. They're just selected from a bunch of music or background noises.
Correct. You can, so you have your preset WAV files. You can
Yeah,
select them. It does have a randomizer, so you can enter a command that says pick a random number within a certain set of files, and you can control obviously start and stop playback for each channel of the mixer independently, and then also the volume of each of the three channels can be set independently. But beyond that, there's no kind of like fancy wave playback going on. It's just playing a wave file.
Basically a DJ bot, right?
Yes.
It's
Okay. I like.
Yeah,
I
so
think
like for
I-
mine, I've got two dials on the top of my radio that I set, one for the sound or the music volume, and then the other one for vocalizations that I can to do that.
Well, that's a lot cooler because I've done it with wave files and combined them together with audio programs from Windows, like Audacity, whatever the hell it is.
Odyssey.
But you can do it live. That's cool. That's actually very cool. Where you could
So you can mix in, the other function that I find kind of fun is you can do streams, and then you can add in, your own combinations of sounds to basically do whatever you want. And then because you can get the motive state back, I could change the lighting patterns to match, for example, that he's happy or sad or whatever.
It also feeds back information on the vocalization itself, like the length of it. So if you want to match, obviously one of the things you'll run into if you're transitioning from a soundboard system to this is on the soundboard, there's only one scream. And on this system, thanks to some complex granular synthesis going on in the vocalizer AI, every scream is different. And so they can be different durations. So if you have an animation, a visual animation on your droid that you want to be synced to the duration of the scream, you can trigger a scream, read back the duration of that upcoming vocalization that's about to be played, and then sync that on the mechanical side as well.
Wow.
So both the audio file and the vocalization would stop at the same time?
You can start and stop each of those three sources independently.
Okay. Wow.
So Michael, how close are we to a mouse droid vocalizer?
Yeah, so close. It's the problem is I really need to kind of like budget my human cyborg relations dedicated time.
I know.
And so, it comes down to like the number of, it's a combination of, I was explaining this to Trevor and Alec the other day. It's like this weighting of like, is the project historically important? Is it interesting to me? And is there mass market appeal / is there fundraising potential, which kind of ties into the mass market appeal question. And so a mouse droid is like up there, but I ranked this embedded port above the mouse droid. So what little spare time I have had to work on this, I put here.
I'm glad you did. This port is amazing, and it's what I've been waiting for ever since I heard this was a thing. Like, I'm so happy this is breaking.
Thanks.
Yeah, this is
We have a
unreal
long,
seeing all
long
of
list
this.
of things for Michael to do. So get in line.
Yeah, the scope of this is unreal. From the linguistics down to the API layer of everything? Like, I didn't realize everybody was working on this simultaneously. Did you have some sort of like Jira set up, or like was it just like independent like contracts with each other as far as like how things were going to work?
We have a very or super effective like 500 thread long now email chain that everything is in. It's super organized. It's wonderful.
The nice part is the pieces we've been working on are pretty much they're pretty independent from each other. So Trevor's boards, you know, the vocalizer can work without the boards. So I'm not necessarily leaning on Trevor, although I am kind of supporting some of the hardware functionality he's building out. And Alex API is just a way of communicating with the vocalizer, which again, you can use his API or you can just kind of communicate directly, although he has been helping to develop some of the kind of command protocol around the command language. But for the most part, the answer is we're mostly, you know, it's all been mostly independent. And actually most of, I think the port was more or less complete at the point when you guys jumped on. So I actually haven't been doing kind of a ton of vocalizer development other than just odds and ends stuff where they need help kind of supporting features on that are part of their portions. So if that answers it. There's no Jira.
It's not quite true. We do actually have, Alec does have one that we have in the background a little bit, but yes, as he said, it's all independent. So we work together.
Well,
yeah, it sounds organized, but it's just a bunch of lunatics working together.
Yeah, pretty much. Well, it's kind of why, you know, it's been a year-long project.
Yeah.
So guys, my question would be, as far as long term, how would this interface with like an NLP processor that's set up to do sentiment, to do automatic response to say somebody speaking to the droid?
Chatbot. Yeah.
I've been working.
That's the stuff that Alex been working. Oh, sorry, Michael, go ahead.
No.
Yeah, well, I was going to just give a very general answer, which is that it's up to you to kind of parse how that input is processed and translated into these stimuli. And Alec, as Trevor said, can probably expand on that as well, since that's an area of his interest.
Yeah, so the droid behind me I've designed to be self-interactive, so it doesn't need an operator to interact with anyone. And this is why I alluded to when I was starting this journey, I wanted this complex vocalizer capability for the AI to interact with people. So in the head of this, it's got a Jetson Nano and an OpenMV to do all the facial tracking and gesture recognition. It's got a re-speaker to do all the audio detection. And essentially what it does is that portento you saw in the video, all it does is it boils it down to an intent. What is the interaction? And that intent then stimulates a response, whether it be an emotive response or whichever. So what you would do in this instance, what I've done with this one is when someone waves at the camera, the droid goes, I am being greeted. And it's a simple chatbot of that exercise. But what it does then goes, how do I feel about that greeting? Am I going to be happy? Am I going to be sad? And then that's where the controlling software goes, okay, well, I'm going to take the happy stance because it's a greeting. I'm going to treat that as a positive. Therefore, I'm going to respond emotionally with a positive intent. So therefore, it will trigger the board with SH0 or SH1, depending on whether it wants a long response or if it's not the first time it's interacted with the person. And then the board will decide on the response, provide that feedback to the controlling software. And you would have seen the, actually I'll quickly just share, you can see the data transfer that is occurring between the board and the controlling software here. This is a data frame package being passed back and forth between the board. So if the board, for instance, and I'm just going to use the direct control because I've disabled the AI for the demo, but I just triggered an emotional response to make it happy, to say, respond happily to the person. And you can see it's immediately triggered a vocalization. And now you can see the happiness indicator is decreasing. If I trigger an angry emotive, because maybe someone hit it in the head because I've got touch sensors in there. You can trigger, you can see it's going to play a 1.5 second response. And then it's shifted the state a little bit to the different emotions. And you can see how it's not binary. Every emotion plays quite differently and changes the state as the droid. So this is where the HCR system and whatever you build are quite compatible into, or they're almost symbiotic in this relationship, is because however the HCR responds, the AI picks that up and carries that forward as well and into the rest of the system. And that's
Thanks
how
a lot.
That is awesome.
This is where I think
the core emotive decision point of how a droid responds for my droid.
Yeah, what's exciting about is building on that concept, and what we've been talking about with B2 is that it's not just about vocalization, it's about animation. And one of the challenges that we all face is the more complex builds that we get. So R2's, is 2 drives and head spin. That's kind of it, really. Okay, he can open some doors, but when you get into things like B2 or Rex, you've suddenly got 15, 20 servos to control, and depend on the patterns of servos, they can emerge again in motion. So what's really interesting is that the work that Michael and Alex and Trevor's done around mixing emotions and then working how you respond that vocally is then transferring that to the animation.
The one thing I've been waiting for, and I've done voice recognition for many years, but it's always kind of one-sided. I can ask a machine to do something, it recognizes my voice, and it will go do things from what I programmed it to do for that response. But there is no, I've yet to find a chat bot that you can actually talk to. And I know that's incredibly hard to do. Voice recognition is pretty much understood, but there is no easy program that I've ever seen that, or used, that can actually respond back to me like, an intelligent machine or human.
But certainly from a speech perspective, that is incredibly difficult to do.
Yes.
That's why I think Michael's nailed it here, because it's not about speaking a specific syntax around how do you address it. Like you would have seen when Luke exits, I think it's Hoth or something, and he's supposed to go to the rendezvous point, and instead he goes to Dagobah, and R2 asks him a question, and it's translated on the screen. The movie tells us that there's a language there, but what Michael's done is focused on the emotion of what that is. And so instead of developing a full chatbot to then respond with all the right phenoms and the right syntax and all that stuff, especially with mine, I've focused on what is the emotion of the moment. Should it be positive? Should it be sad? Should it be mad? Or should it be happy? And I've oriented around Michael's work. So when my kids come in and they wave hello to R2, it greets them with a positive response. Whether it's consistent every single time is irrelevant. The emotion is there, and that's what they feel. So they really enjoy it.
That's really well put, Alec. And to even expand on that a little bit, I mean, that's the voice, the kind of sentience behind R2 and his personality and speech is Ben Burt. So in the same way, all this software is doing is reproducing the process that Ben Burt executed to create this voice. So in the same way, it's not like Ben Burt had a book that he had composed that translated from phonemes into like English speech. He is just using these phonemes to build emotional conveyance. So the full depth of what R2 is actually conveying is these emotions, and that full depth is encapsulated within the vocaliser software. So the kind of full extent of kind of intelligence and emotional sentience that R2 possesses as a character canonically is all there in the software. So as Alex said, it's an easier feat than trying to replicate the kind of verbal and emotional sentience of a human.
Yeah.
Or
Yeah.
C3PO is incredibly hard to do, even nowadays. Even if you use Alexa or Google or whatever. Yeah.
That's why I'm dreading V2.
Yes.
V2 it's voice acted, so to replicate V2, yeah, that's a whole different game.
But then you look at what they did for, Val Kilmer for Top Gun, and they've taken clips of him speaking and recreated his entire speech pattern digitally. So, given enough time,
Somebody glued that together piece by piece to make that.
Well, you did that with Dio, right, Michael?
The tech exists. So Respeecher is one of the popular commercial software suites that does this. And this is what Disney used for Mark Hamill's recreated voice in all of the recent Mandalorian and Boba Fett stuff. I think they actually used it for James Earl Jones in Obi-Wan. So the technology exists, but it's commercial, it's not publicly available, and it's not being done in real time. It's very, very, very intensive kind of preparation and post-processing. And it's definitely not running on a teensy inside of an R2.
Right.
So.
Yeah. My point is that, 25 years ago, none of us had iPhones and Androids sitting in our pockets doing more than we could do, when some of us grew up, typing stupid notes on the calculator. So yeah, I think, the point I'm going for is that technology is out there now, and yes, it's expensive and proprietary, but as we've seen how things move, that's definitely something that I can see us moving towards in the future some point. So
maybe soon. A cell phone's powerful enough nowadays. The processors. Shit, you get 8 processors and a lot of memory. But there is no interactive computer that I've been able to contact on the internet or through other things that I've done that you can actually have a conversation with it.
Well, I think at the end of the day, the conversation that's happening with a droid interaction is between the droid operator and the person interacting with the droid. I don't want to have a computer decide what the appropriate response is, because people are way too complex. I think this is a perfect surrogate for a sentient droid, is have a sentient person determining the trigger responses to the exact situation that we're all experiencing.
I've noted with when my kids interact with it is they will fill in the blanks. So they will wave good morning to it, say hello, and it'll respond positively. At the start, they'd ask, "Oh, what did it say?" And I'm like, "You got to work it out." It's talking to you.
And that's what's really cool. Yeah.
And so we taught because I tied it directly to the emotional construct that Michael defined. It's actually freed up a lot of that complexity. So it now means whatever you want it to mean, as long as it's within the context of what you're thinking. So kids will definitely connect with it far better than an adult will, because an adult will be like, "Oh yeah, just play the sound," and the emotion is not always tied to it. But kids, I've definitely noticed they infer the conversation on the back of that, because they tie it to the emotional response.
Awesome. The word brilliant doesn't even begin to describe how awesome this whole project has evolved into. It really is taking our love of droids to the next level. Yes.
I think it's more than that, people that build plastic robots. Sorry, John.
I think it's more than that. It's actually seeing a lot of really, really significant progress in droids and how they're built, because the whole droid building area has been quite stale in electronics for a long time, and this is real innovation.
Yes. Yes.
That's very true.
Yeah, the physical build I think has evolved definitely, but the electronics
yeah.
and programming is now jumping back. And realistically, what we're all doing is recreating plastic builds or metal builds of TV or film stuff, and the amount of kind of R&D, intelligence, brains, and development that goes into it is amazing. It's a fantastic community, I think, to get that together.
Yeah,
The motors, the speed controllers, the now with integrated circuit boards, Arduino, and other things, has evolved considerably. When I started building combat robots in 1997, and we developed motor controllers and found motors or created motors to make things more powerful. Still radio controlled. It's all radio controlled. Still is. But now there's getting to the point where we have enough computer power, even in very small devices, even like a cell phone or just a circuit board or Arduino or Raspberry Pi. That's changed. The only next thing to do is how do we interface the device? Do we control it with a joystick and a radio, or can we talk to it and it understands what we can do? We can do that. I've done that.
Stephen, can you just explain what your combat robot is, please? Because you keep mentioning it, but I'm not entirely sure what you mean by it.
I started building combat robots in 1997. I've done it since then. I fought in BattleBots and Robo Games and I don't even know, 7 or 8 other events. I built machines for Maker Fairs and Robo Games. I've radio controlled robots like what most of your R2 are. Mine were 300 pounds made out of steel, and I drove them around hundreds of thousands of people. Never ran over one. Came close a bunch of times, but never did. And what I see with what happens and what you guys are building are beautiful models of things. I don't have the artistic ability to build something that's accurate as you do. And I usually build out of steel or aluminum anyways. But what I found is for robotics to advance, they have to be more autonomous. They have to be able to sense their environment and drive around and not run over people and maybe deliver a package to a GPS coordinate or to an address. That all is the evolution that is slow to advance, and it hasn't advanced in the 25 years plus that when I started doing this. It's better now than it was, but it's a slow process. And we still talk to the machines either mechanically by hand and we don't turn them loose. So there's a thing that's like we have to make them smart enough and safe enough to interact with us daily. That's kind of where I'm still at and always hoping for.
Stephen, how many have you built over the years?
75. About 75.
Have they all been combat robots?
No. Probably way less than half of them. A lot of them I've turned loose through the evolution of sensors with ultrasonic sensors, infrared sensors for judging distance or something to run into. I've also done things with video cameras, looking at what do I want to say? Looking at edges and borders and blobs, something that's in front of me, and judging the distance between them. I've also used the Connect sensor from the 360 that shot out a bunch of red dots and could read them back by their reflection. which work good, but it only works good indoors because out in the sunlight it doesn't work. There's always been this thing that always got in the way. And well, you guys are really smart, and that's why I come here, is to maybe, you know, fill in some of my blanks. Because I mostly do it on my own and have to do it through research on YouTube.
Sounds like,
or
Steve, you're going to lead the next robot revolution that's going to be leading us to Terminator 2. I think robots are smart enough right now.
No, that's not true. I do not believe that you should arm a robot. I mean, I've done combat a lot, but I would never put a gun on a robot and give it the choice of using it. That should never happen. So no, there's no Terminator in my ideology. No. I don't trust machines.
We're kind of doing that with the self-driving cars, though, aren't we?
Yes.
Yeah, getting close.
Yeah.
Getting close.
Yeah. You got this, you know, thousands of pound missile, really.
Yeah, 3,000-pound missile.
Here's a driving tip for you. If you're in two lanes merging into one and no one will let you merge in nicely, just cut in front of the Tesla, because their anti-collision system will allow you to do that safely.
Really?
I always
That sounds like from experience.
You always turn on your right turn signal if you want to move left, and that screws up the humans.
No, we don't drive on that side of the road. We drive on the correct side of the road on the left.
Okay, well, turn on your left turn signal and then move right. That's a strategy that I have used with some humans.
Yeah.
All right, so are we complete with all the previews of?
Yeah, I think we are. I think we're moving on to breakout rooms now. So I'm just
woohoo!
Recreating the breakout rooms, which will all be randomly. So I've done 4. We've got 3D printing, we've got code and electronics, we've got sound and vocalizers, and then we've got a general chat one. So I'm just going to open the rooms, but people I think can move between the two. Not between
have you got a paint one? I'm happy to do paint.
Yeah. I'll add a room then.
No one will go in that room because it's like watching paint dry.
Just a
Painting
quick
and
Didn't John Gowan want a room all to himself?
Yeah.
Just a quick thought before we all get sent off on the way. Obviously, Sam is now constructing battle bots of sorts, so maybe Steve and Sam could have a conversation about that kind of stuff.
Oh, what, combat robots? That would be cool.
Yeah. Yeah. And before we get off, I haven't been on for like months, so it's good to see you all.
Tim, that's good because I've got lots of ideas for you.
Oh no!
Quickly leave Tim. Tim, leave before he tells you.
Who's the guy from?
Gonna open the rooms now.
Who is the guy from New Zealand? That guy's great. I love that guy.
Richie.
Hello.
Michael, you need to stop recording, but you need to open up that you can select your breakout room.